Good morning, students. Once again, I welcome you to my video lectures on network analysis. And students are to be more familiar with independent and dependent sources. So, to familiarize them, I have taken an example. So, this is a network consisting of 5 elements. So, this is a current source. This is an element. We don't know what is its nature. This is also an element. This is also an element. And this is a voltage controlled current source. Now in this network comprising 5 elements, we have to find the power absorbed by each element in the circuit. So sometimes elements absorb power or sometimes they supply power. So before going into power absorption or power supply, so first you become familiar. For example, if an element is absorbing power, then current enters at the positive terminal. This is absorption of power. If it is delivering power, then at the positive terminal, current comes out. This is delivery of power. We shall use notations. For absorption, I will use plus sign. And for delivery, I will use minus sign. Okay? And at the end, according to law of conservation of energy, on adding absorption of powers and delivery of powers, you should get 0 answer. Now we shall work out this problem. First, this is an independent current source. So 7 ampere current source, and at its terminals it is possessing 8 volts. So at the positive terminal current is going out. That means it is delivering power. So if it is delivering power, use minus sign. 8 into 7, 56. Minus 56 watts. Next, take this element. This element is carrying a 2 amperes current at 8 volts. At the positive terminal, current is entering. At the negative terminal, current is leaving. That means this is absorbing power. 8 into 2, 16. 16 watts. Use plus sign because it is absorbing power. Now coming to this element. This element voltage is Vx. This Vx is appearing here. That means it is controlling the value of this. Vx is a voltage elsewhere in the circuit. This is what I explained earlier. Vx is controlling this. So what is Vx here? Vx is 12 volts. But Vx direction is, this is plus, this is minus. But in the circuit, this is minus, this is plus. As far as numerical value is concerned, 12 volts. So current is entering at negative terminal. So if current is entering at the negative terminal, that means it is delivering power. So when it is delivering power, you multiply 12 into 5, that is 60. 60 watts. It is delivering power, use minus sign. Next, coming to this element, 20 volts. So 8 amperes is entering positive terminal and leaving the negative terminal current. Therefore 20 into 8, 160 watt. So current is entering the positive terminal. That means it is absorbing power. When it is absorbing power, use plus sign. Plus 160. Now coming to this last element, it is the source quantity is 0.25 Vx. That is 25% of Vx. But Vx direction is opposite to this. Vx direction is plus minus, but in this network, after completing the connection, This has become negative and this has become positive. Therefore, direction of Vx has reversed. Therefore, we have to reverse the direction of this source because Vx has changed, direction of Vx has changed. Therefore, here you make a change in the direction of the arrow. Now, 25% of Vx means 25% of 12 volts, that is 3 volts. 3. Source quantity is 3. Now, current at positive terminal, current is coming out and current is entering at negative terminal. That means it is supplying power. It is supplying power. So 20 into 3, that is 60 watts. It is supplying power, use minus sign. Now you add minus 56. According to law of conservation of energy, you should get 0. Minus 56 plus 16 plus 16. Next, plus 16 plus 16 minus 60 plus 160 minus 60. Add 120, 176. 160 plus 16, 176 equal to 0. This is how you have to work out the problem. So be familiarized with these concepts, and this is an example I have solved, and in the coming sessions I will work out more and more problems. Thank you.